How's it going, guys? It's Going Off Grid, and we purchased the big brother. This is actually, I believe this is two sizes up. There goes a 1600, a 25, and a 3500. Got the 3500 because I believe it's the same inverter, but with slightly heavier duty MOSFETs inside. So they go from a 2500 to a 3500. It probably has the same transformers and all. And today we're going to be testing it. First, we're going to test it with a resistive load, which is just a 1500 watt inverter. So let's try that. We'll try high and low. This has 750 and 1500. Okay, so we're going to hit power, and then I'm going to hit low right away. Low, so that's on low. And where is my, let's turn that back off. Let's find the, there it is. We got the kilowatt meter. We need that. Can't forget about the kilowatt meter. It's got a tight plug, that's for sure. It's good. Gotta have a tight plug. Anyways, we are going to be, okay, 113 volts. That's good. There's their voltage there. Sorry. 60 hertz. Low, high. Where's the watts? Maybe I gotta turn this on to get watts here. Okay, that's on low. Volts are staying at 113. Man, that is rock solid. I already checked the sine wave. It looks good. I might show that later in the video. There. We got 750 watts. Now, we're going to hit high and see how it does. Let's see if we can get this. There. Stay on. Here's high. And here we go. We got to start climbing. Here we go. 1100. 1200. Holy smokes. Okay. I was going to say, dang, it's running a 1500 watt inverter. I was going to say, that's really impressive for an inverter. Oh, it just turned back on. Let's look at the voltage and do the exact same test again. Okay. And let's try that again. So this is straight to high. Down to 112. Holding 112 very well. That's awesome. Okay, well, okay, essentially this is just, it's a 1200 watt inverter. 1200 watt pure sine wave inverter. Now, it's 24 volt. It's nothing fancy. Like, the MOSFETs are literally bolted to the outside of the case. This is not going to be able to do 1200 watts continuous. There's 0% chance. Now, that means it could surge for a decent amount of time at 1200 watts till it overheats or blows up, one or the other. It's a very, very cheap inverter. This was $95 shipped to my house in Canada. That means in the States you're looking at about, I don't know, $65, something like that. For a 1200 watt pure sine wave inverter. The sine wave is quite nice. Yeah, let's go look at the other inverter we have in the lineup. So my first video is the younger brother, little brother, 1600 watt 12 volt. Then we got the big brother, 24 volt. And now we're going to check out another inverter. Okay, so now we're in the garage. Trying to get the light to turn on here. There we go. This is my only 48 volt battery I have, is the one connected to the reliable. That's a good Chinese inverter. This, we'll find out. This one is a super cheap Chinese inverter, like the stickers coming off. That's how cheap it is. There we go. Let's get that back on there. There. It's 48 volts, 1600 watts. Cut that in half at least to get maybe what it is. Let's plug in the same inverter. Let's see. This is one of those multi plugs. Not a big fan of those, but they kind of work. Now, Let's see what we got going here. We'll turn it on. Hopefully this, oh, the battery's low. It's not going to last long. Alright, so voltage is looking good. But let's look at watts first. We'll go low. Immediately the fan's turned on. Not looking too bad, watts wise anyways. Let's go to volts. Down to 109 volts, so it's less than the other inverter. There's watts, now let's go to high. As you can see, I'll hit high. There's high. Immediately stops. This is 800 watts. It's more like 700 watts. But okay, there you have it. So essentially on this brand, which like I don't even see a brand, there's like no brand. If you see one that looks like this, it is a little less than half wattage, and it's the same design. I'm just gonna take this off. I'm gonna discharge the MOSFETs, which are not MOSFETs, the capacitors, which it has hardly any. It has all the MOSFETs bolted to the side, same thing as the other one, except for this one doesn't even have hardly any fins. Like the fins are like a couple millimeters thick. And then now we'll have to do inductive load. Let's see what these things can start inductively. This is where they might blow up. Okay, and just to show what I have used this other little inverter for. Let's see, open this up. Oh, it's a little wet. Hopefully it's not dead yet. I used this. We had a little Santa Claus parade where I live, and I connected this thing to my tractor. Oh, it's wet. Let's see if it's raining out here. Oh, it's not very good for it. There we go. Well, we'll dry this thing out before we try and start it. Had a little float, had lights all over it. It looks very crappy, but once the lights are on, it looks awesome. So that's what I use this thing for 65 bucks. Super happy with it. Worked great. Yeah, we're inside my house. I think that'll dry it out. Yeah, I think that'll do it. Okay, this might be what kills it. This is a shop vac, 9 amp, it says. But that's usually running, and it usually has a big surge. Now this is a smaller shop vac. It's not a full-size shop vac. I mean, a full-size shop vac on one of these little inverters. It's kind of just suicidal from the start. So let's try this first. See how it goes. Alright, so we are hooked up now. I have this battery being charged. This is a 3 kilowatt hour battery. It could run a lot more than 1200 watts. You could probably run more like 4000, but anyways, let's give this a try. Going part 2. Okay, so we got the vacuum cleaner hooked up to the second of the what does it say? Here we go. Tackalakin? No. I don't know if it's Tatalikin or Tatalikin or whatever it is. Anyways, this is the second one, the bigger one. We're going to try this on it. 9 amp. Vacuum. Let's give it a try. Let's see how it does. Wow. It actually started it. I kind of like these Tatalikins or Tatalikins or whatever they are. Like I said, it would probably overheat if I kept running it. That's going to be a test that I do later. But for a El Cheapo inverter that can do 1200 watts for less than $100 shipped to my house in Canada, that's not bad. If you need just a super El Cheapo, I'm sure this could do 600 watts continuous without overheating. No problem. Now, 800, not sure. 1,000, probably not. Maybe 1,000, maybe. But if you're looking for a 600 watt continuous inverter with a 1200 watt surge, I think this is not a bad inverter. The sine wave is clean. Let's see if I can dig out my, oh yeah, here it is, my oscilloscope right here. Okay, we got the oscilloscope hooked up. Now, let's take a look at this all again. Let's look at the surge when we start the vacuum. That's looking pretty good, man. For that, these little inverters have come a long way. Okay, so we're back to the 48 volt, essentially no name brand. At least the other one has a name brand to go by. This one, no name brand. And let's see, will it start the same vacuum? Now, obviously this is about 400 watts less output than the other one, and we're gonna find out. It started. I don't know how the heck it started. That is incredible that it actually started. I was not expecting that. I thought it was going to blow up for sure. It made a horrible sound. Let's try that again. Let's look at the sine wave again. Wow. What a soft start. That is crazy. Look, it's putting out over 800 watts. It's putting out more than half of its rated capacity. That's really good. That's crazy. I'm actually impressed. Okay, so now we got somewhere around the 1970s dehumidifier, and this should pose a challenge to this inverter. Let's see if we can run it. Looks like we're ready to go. Let's see. Holy smokes, it started it too. Just like that. That's crazy. Inverters have definitely come a long way, even the Chinese ones. Especially the cheap Chinese ones. Okay, how about we try an early 2000s air conditioner. I believe that's when this was purchased. I've had this for, well, as long as I can remember. So, well, not quite as long as I can remember, but anyways, let's try it. We got, let's put it to as cool as it can. Oh, you can hear it. That's where it turns on. That's where it turns off. Let's turn it down first. We'll go to the fan setting. Okay, it's blowing out. We go to AC, which does nothing because the thermostat hasn't engaged yet. We're taking 50 watts. And let's see what happens when we start turning this up. There it started. Holy smokes, man. This thing is a beast, this little inverter. That's incredible. The technology in these things has just come such a long way. Now, just remember that I'm not saying these are going to last a long time. I'm just impressed with what they're doing. Short time, yeah, no idea on long term. I'm going to have to do long term testing on these. I'm going to go ahead and say they're probably not going to last that long because they're super cheap. But that's putting out cold air ready. Back's not really warm yet, but let's see what kind of voltage we're holding at. 112 3/4. That's not bad at all. Wow. We're gonna try something else here. Okay. So very impressed with the, what is that? Tachylicon, whatever it is. Next video, we're gonna do a comparison between the power jack and the Tachylicon. Now, this inverter is just poorly designed. The transformer is just far too small. At one point, it used to call this thing a, what did it call this thing here? I believe it was 3,000 watts. Oh, look at that. And I found after about 500 watts, it became more or less a square wave. And at that point, I don't consider it usable. So that thing can produce a pure sine wave up to around 1100, 1200 watts. And we'll see how this does. Now, this is a split phase inverter. So this is 500 watts per leg though. So it technically can do 1,000. But if you're gonna pull out of one leg, and both these legs used to be wired to the same line. I wired them so one leg is line 1, the other leg's line 2. It made it much more usable. But we'll have to do a comparison to see which one of these is better. Now, as you can see here, there is a huge, absolutely huge size difference, and that's because this is a high frequency inverter. This is a low frequency inverter, and this, they were not going for optimum size. Like when you open this thing up, there's just tons of space inside. So it's just what they did. So, but we're gonna give these two a comparison. Now, I'm betting that this can start bigger loads than this one, but I'm not sure. We're gonna find out. Like, these are looking to have a really nice soft start. Well, this has a soft start as well. So we're gonna find out. Anyways, hope you guys enjoyed the video. Please hit the like button, it helps a lot. How's it going, guys? It's Going Off Grid. And here we got a bunch more Chinese inverters. This is the 1600 watt that we already showed in a few videos. This is its bigger brother, same brand. This is a 3500 watt. And then this is another 1600 watt. But this one is 48 volts. So we got a 12 volt, a 24 volt, and a 48 volt. I couldn't get this brand in a 48 volt, or I would have. But this is just another random Chinese brand, actually one of the cheapest ones I could find. This is what I paid for them. They're 65, this one's 95, and this one's 98. So this one, well, let's go in order. This is the El Cheapo, $65. This one ran 640 watts, but then would cycle in and out, in and out, in and out. But actually, when I put low input voltage in, it actually ran 600 watts, right around there, a little under 600 watts. So this, I would consider this a 500 watt inverter. Works really well. Very, very small form factor. Works very well. We got 4 input, wait a second here. No, yeah, 4 input FETs here and 4 output right here of these little FETs. And you got 1 transformer fused for 80 amps. Then moving up in the world, we go to this 3500 watt. This 3500 watt here has nice thick outer cables, but the inner cables, they're kind of lacking. At least it's 24 volts, but still lacking. This one was also kind of lacking right here. You can see nice thicker outer cables, but really thin inners. This is also fused for 40 amps, but now this is 24 volts. So this should do about, what, 1600 watts? Theoretically from fusing, but it does not, as far as I know. I believe this is probably under 1500 watts. We're gonna have to do some testing, but just from what I'm looking at, so this has 2 banks, so 4 FETs per transformer, where this one had 4 FETs for 1 transformer. So this is twice as much. So if this could do right around 600, I call it 500 watts, it could actually do it right around 600, 640 tripped it. So This could be around 1200 watts. And this is probably more like 600 watts, like max. Same with this. This will be max. It had a good surge. We'll see what this one has. Tidiness, that bracket is on an angle. This one's straight. It's not bad. They're still, the contact's good. They're tight. I checked it for tightness. Tightness all on this side. These aren't bent. These are nice. And yeah, all around it's not too bad, other than the really thin input cables here. But other than that, it's not looking too bad, honestly, for a cheap Chinese inverter. If you need 1,000 watts for $100, that'll do it. Now we're moving to the 1,600 watt. Let me get down here, sit down in my chair, and get a little bit closer. And this one here, it looks like, I'm looking for, okay, so input FETs are here. There's 3 sets. How the heck is there 3 when there's 2 transformers? That's interesting. Looks like they're all being used as FETs. All the pins are being used except for, you know what? I wonder if it's just these ones here. These ones here. So this set is for this transformer. This set's for this transformer. And I wonder if these 2 are being used as diodes. So they don't have any resistors or anything in front. Oh, they do on the side, actually. Way down in there. Let's see, 1, 2 there. One's got 1, 2. You know what? Nope. Those are, I think these are just 3 sets of FETs. I'm not sure how. They must be all just sharing current, and these must be in parallel, these 2 transformers, as I'm guessing. Output FETs, large FETs. Not exactly sure what they are, but they are a larger FET. So there's 4 of them, just like this one. I don't know if I showed that on this one. Right here, it's 4 larger FETs. I do like seeing the larger FETs in the output, but depends. Like if you have 8 smaller FETs, it'll do the same job, if not better. But I find, I don't know, I kind of like the larger FETs better, but doesn't mean they are better. This one here should do, I'm guessing this is going to do at least 800 watts. Probably 800 watts. So I think this one is going to put out the most power, but not by much. So it's going to go least powerful, obviously. And then this one will be just lagging behind this one. Would be my guess. But we'll see. It might not. Maybe this one will be a surprise here. I do like the cabling on the inside. It's a lot heavier duty. The output cabling is a joke on this one. It is so thin. Oh my goodness. And then the output cabling on this one is also pretty thin, but a little bit thicker. And then of course this one's thin, because we know this one can't handle much. So anyways, we're gonna have to make a video testing all these guys. I just put together this battery here, I'm charging it so I can test the 24 volt, because this is the only 24 volt battery I have. Once that's done, we can do a test video.